Hi math fans, welcome to Scientific Notation Day. Today we're going to explore how we can abbreviate very large or very small numbers in math. We're going to review a little about powers. When we're dealing with powers, remember we have a base and we have an exponent. And the base is the number we work with. The exponent tells me how many times I'm going to multiply that base times itself. So if I had 10 to the third power, I'm looking at 10 times 10 times 10, and I'm getting 1,000. If I had 10 to the second power, that's just 10 times 10, and that's 100. Yesterday we were talking about patterns. And we recognize that for each time our exponent increases by 1, we multiply this number by another base. So if I wanted 10 to the fourth power, instead of saying 10 times 10 times 10 times 10, I could just go to the previous value and multiply it by another 10. But I'm hoping at this point, at least as far as powers of 10 go, that you're starting to see a pattern. And that the exponent, when my base is 10, tells me how many zeros I'm going to have after the number 1. So 10 to the first power, I have the number 1 and 1 zero. 10 to the second power, I have the number 1 and 2 zeros. So for every exponent, every power of 10, the exponent tells me the zeros in the number. Yesterday we talked about anything to the 0 power, and any number raised to the 0 power is always going to be 1. So it has 0 zeros, the number is 1. The rule is, when the base of a power is 10, the positive exponent gives you the number of zeros after the 1. So that's what we're going to go with for our powers of 10. We need our powers of 10 when we talk about scientific notation. So now that we have that, let's move on to this. Scientific notation is an abbreviation we use for very large and very small numbers. It started when scientists were having to write really large numbers, talking about distances in space that were trillions and billions of light years away. And instead of writing those large numbers, they used an abbreviation system that consists of 2 factors. One is a decimal number with only 1 digit in front of the decimal point. So a number that's greater than 0 but less than 10, and that's going to be multiplied by a power of 10. So the product of a number that's greater than 0, less than 10, and a power of 10, and I'll show you what that looks like in a second, we can also say that the first factor has the decimal point behind 1 digit, and the second factor is a power of 10. The product is written as standard form. So here's an example. If I have the number 9,000, I can break that down into 2 factors. I can say 9 times 1,000. But another way to say 1,000 is that it is 10 to the third power, because 10 times 10 times 10 is 1,000. So I can write this as 9 times 10 to the third power. That's considered scientific notation, because 9 is greater than 0, less than 10, and then we're multiplying by a power of 10. So standard notation is the way we write numbers without abbreviation. If I have this number, 2,700,000, that's considered standard notation. 2.7 times 10 to the 6th power is the scientific notation of the same number. So we write numbers in scientific notation by taking the standard form. If I had 93 million and I wanted to write that in scientific notation, what I'm going to do is I am going to take the whole numbers, or the natural numbers in that number, and I'm going to write that down, but I'm going to move the decimal point that is always at the end of every number. I'm going to move that until the decimal point is behind the first whole number. So I move it 1, 2, 3, 4, 5, 6, 7 spaces. Then I remove all the zeros that are to the right of the last natural number. I write the number of spaces I've moved as the exponent in the power of 10, and then I write the two factors as one whole term. So 93 million would be written as 9.3 times 10 to the 7th power in scientific notation. So the flip side would be if I had to write a scientific notation number in standard form. If I have 3.5 times 10 to the 6th power, what I'm going to do is I'm going to start with my 3.5, my decimal number, and I'm going to write the first factor without the power of 10. I'm going to use the exponent in my power of 10 to determine how many spaces to the right I'm going to move that decimal point. In this case, I had to move it 6. So if I started here, I moved it 1, 2, 3, 4, 5, 6 places, and then I had to go back behind the scenes. You didn't see this. But these zeros weren't here. Once I figured out how many spaces to move, then I put the zeros in. So I go back, add my commas, and my number is 3,500,000. You can find this handout on Blackboard and the homework assignment that goes with it. See you soon.